Hi everyone and welcome back to another lab. In today's lab, we are going to dive into the intricacies of configuring and verifying VLANs across multiple switches. VLANs or virtual local area networks are an essential component of network segmentation to enable efficient traffic management and security across the network. By extending VLANs across multiple switches, we can create logical networks that span physical boundaries, facilitating better organization and resource allocation. So, with this being said, I will do the usual where I go over the objective of the lab, then go through the topology, and then switch table, and then go through the lab task, and finally walk you through the lab solution. So, regarding the lab objective, the primary objective of this lab is to gain hands on experience in configuring and verifying VLANs that span multiple switches. We will explore how to create VLANs, assign switch ports to VLANs, configure trunk links between switches to carry VLAN traffic, and verify proper VLAN operation across the network. Throughout this lab, you will develop a deep understanding of VLAN implementation and troubleshooting techniques in multiple switches environment. So, regarding the lab topology, as you can see on the screen, it consists of 6 PCs and 2 switches. So, we have PC1 and PC2 and PC3 are connected to switch 1. PC1 is going to be part of the IT department and it resides in VLAN 100. PC2 is going to be part of HR department and it resides in VLAN 200. And PC3 is part of the sales department and it resides in VLAN 300. Similarly, PC4 is part of the IT department and it resides in VLAN 100. PC5 is part of the HR department and it resides in VLAN 200. And finally, PC6 is part of the sales department and it resides in VLAN 300. All these PCs are connected to switch 2. We can see that switch 1 and switch 2 are interconnected via Gig Ethernet 01 and Gig Ethernet 02 respectively. So regarding the switch table, we can see that it's very self-explanatory again. We have the device name, switch 1 and switch 2. We have the interface ID and then the interface mode that defines the operation status of each interface and what sort of configuration we should be using for each of these interfaces. We then can see the VLANs column where, for instance, if the interface is operating in trunk mode, we can see that the allowed VLANs on that trunk is 100, 200, and 300. Whereas if the interface is operating as an access mode, we can see that is part of VLAN 100. And you can see that so on and so forth. And then if I scroll a little bit down, you can see the SVI table. And the SVI table will help us build the SVI interface configuration. You can see that we are going to build SVI for VLAN 100 and 200 and 300 on switch 1 as well as on switch 2. Each SVI will have its own IPv4 address. And if I scroll further down, you can see the host IPv4 address where we are going to assign IPv4 addresses for each of our PCs. If I then move down, you can see the lab task. And first task, you can build the lab where you can build it virtually or physically. You need to build the lab where you connect all the cables and connect all the devices together according to the lab topology provided in the diagram that we have seen earlier. And if we then move to step number 2, we are going to connect to the CLI of the both switches where we are going to enable the privilege execution mode. And then we are going to do some config changes to change the host name according to the lab topology. Then we move to step number 3, where we are going to configure some VLANs and SVI configurations. So on switch 1, we are going to create VLAN 100, 200, and 300. We also going to name each VLAN with the appropriate department as per our topology. We then are verifying the configuration as we have configured the switch accordingly. We will then configure the SVI as showing in the SVI table above. And finally, under this step, we will verify the SVI configuration, and we will be doing this on switch 1 as well as switch 2. So the fourth step, we will be configuring the trunk ports on switch 1 and switch 2. So looking at the tasks 1 all the way to 6, what we will need to do is we will need to set the interface to operate in trunk mode, and we will set the allowed VLANs to only allow 100, 200, and 300 VLANs. We will also set the link or the interface description, and then we are going to verify the trunk configuration and check the admin operation of the interface. Then we will set the native VLAN to 100, and that will be applied on both sides. And then finally, we are going to verify that the native VLAN has changed from the default VLAN, which is 1, to 100. And then once we have done that on interface gig Ethernet 01, we will be doing the same on gig Ethernet 02. And we are going to repeat this configuration on switch 2 as well. We then move to step number 5, where we are going to access the port configuration on switch 1 and switch 2. So we will be assigning fast Ethernet 01 to VLAN 100, for instance, fast Ethernet 02 to 200, and fast Ethernet 03 to 300. And we are going to include a description for each of the interfaces, and we will force each port to operate in access mode only. And then finally, we will verify our configuration and then move to step number 6. So step number 6, we will then configure each computer with the appropriate IPv4 address and the subnet mask, and we will also verify that. And then move to step number 7, we will be doing some connectivity test between devices within the same VLAN. Then step number 8, we will be testing what happens if PC1, which is part of the IT department, want to communicate to the sales department. We will check if the ping is successful, and then if it's not, then we will provide an explanation as to why. And then finally, if there is a problem with the configuration steps, we will then do some further troubleshooting where we can check the VLAN configuration on each switch, where we can verify each port assignments to the VLAN in question, and we are going to ensure that the trunk is operating according to the task requirements. And then finally, we will verify IPv4 addressing across the network. Okay, now we get to the point where I ask you to pause the video and give this lab a try yourself to test your knowledge and skills. So in this video description, I included the lab task and the lab document so that you can download it and practice at your own pace. And I also included a couple of packet tracer labs. The first one is the pre-lab, which is for those who want a lab that is ready to go for configuration and practice. And the other packet tracer file is the post one, which is for those who want to have the full solution, just in case if they wanted to double check their configuration against my configuration. So again, pause the video now or just keep watching. So what I will do, I will log into switch 1 CLI and do this. And the first task that I'm going to do is change the host name on switch 1 and switch 2. So the first task is already been done, the second task is already been done, and then the third task is we are going to configure some VLANs and SVI configuration. So on switch 1, we are going to create VLANs 100, 200, and 300, and we are going to name each VLAN accordingly. So what I'm going to do, I am going to say VLAN 100 and then set the name to IT department, then hit enter and then up arrow multiple times to get the VLAN 100 command and change it to 200. And then change the description or the name from IT to HR. And then finally, we need to do the same for VLAN 300. And then we're going to change it from HR to sales department. Let's do the same on switch 2. And now let's verify our configuration. And we can do this by saying do show VLAN brief. And you can see that we have created these 3 VLANs. You can see the VLAN ID here and the VLAN name. We have the IT department, we have the HR department, and the sales department. All of them right now are active. However, we haven't assigned the switch port yet. Let's do the same thing on switch 2. And we have the same output here. Next, we are going to tackle the SVI configuration where we are going to create 3 SVI interfaces. So we would say interface VLAN 100, and I will say IP address 192.168.101.1, and the subnet mask is /24, which is 255.255.255.0. And then I will up arrow this. I will do the same for VLAN 200. And then I will change the IP address command from this IPv4 address to 192.168.102.1. And the subnet mask is going to be the same, /24. And then do the same thing for the last SVI, interface VLAN 300. And then we are going to configure the IPv4 address to 192.168.103.1/24. Let's do the same thing on switch 2. So I'm going to say interface VLAN 100, IP address 192.168.101.2/24. Do the same thing for VLAN 200. And here is going to be IP address 192.168.102.2. And then do the same thing for VLAN 300. And then the IPv4 address will be 192.168.103.2/24. So with this being done, let's do some verification. I'll just hit end and I'll say show IP interface brief. And then I'll maximize the window. And you can see at the moment we have created 3 virtual interfaces. We have VLAN 100, VLAN 200, and VLAN 300 virtual interfaces, and each one is configured appropriately according to the IPv4 address table or SVI table. And right now, as you can see, the physical layer is up, however, the data link layer is down. And the reason why this is down is because the SVI hasn't been associated with a physical interface just yet. Now let's do the same command on switch 2. And you can see that we have created the 3 SVIs accordingly. So next we will be tackling step number 4, where we are going to do some trunk configuration. So on both switches, we are going to tackle interfaces gig Ethernet 01 and 02. So what I'll be doing, I will use the range command. So I'm going to config terminal, and then from here I can say interface range gig Ethernet 0/1 and then dash, and then I would say 2 to set the range from 1 to 2, and then I will hit enter. And from here, I can then set the interface to operate as a trunk mode, because at the moment, if I were to actually check the current status for this interface, it will show that is operating as an access mode. And you can do that by issuing do show interface gig Ethernet 01 switch port. And here you can read that the operational mode is static access. So we will need to configure the interface, both interfaces, gig Ethernet 01 and 02, to operate as a trunk. So with this being said, what I'll do, I would say switch port mode trunk, and I'm going to also set the allowed VLAN, switch port trunk allowed VLAN to only 100, 200, and 300. And let's set the description for both interfaces as well. So we would say links to switch 2, link to switch 2. We will also change the native VLAN from 1 to 100. So if you want to check the current native VLAN, what you can do, you can say do show interface trunk, and here it will show you that the native VLAN is set to 1. The current operation is trunk mode, and it uses .1q as part of the encapsulation process. And here in this section, you can see that each interface is going to allow VLAN 100, 200, and 300. So to change the native VLAN on the trunk, we will need to use this command, switch port trunk native VLAN to 100. So you will get a lot of error messages going back and forth between switch 1 and switch 2, and that is normal because there is a mismatch between both switches, and it is very important that the native VLAN matches both ends in order for the trunk to work accordingly. And as you can see here, we see a CDP error message that indicates that the native VLAN is mismatched between gig Ethernet 01 on switch 1 and gig Ethernet 01 on switch 2. And the same applies for gig Ethernet 02 as well, since we are configuring both interfaces at the same time. So now let's verify our configuration, and I'm going to just up arrow multiple times to get to that command. And here, what we can read, we can see that under the native VLAN, you can see that it changed from 1 to 100. Okay, so next, let's configure the other side, which is switch 2. So I'll do the same thing. I'll go to config terminal, and then I will use the interface range command. And here I'm going to say switch port mode trunk switch port allowed description link to switch 1, Now that we set the native VLAN to 100, we shouldn't be getting these log messages anymore. And let's verify our configuration on switch 2. And we'll do that by saying do show interface trunk. You can see the native VLAN is set to 100, the status is trunking, and the encapsulation method also should match both ends, and at the moment is using .1q, and that is being implemented or applied on Gig Ethernet 01 as well as 02. We can see on this section the VLANs that are allowed on the trunk, that is for Gig Ethernet 01 and 02, and currently are set to 100, 200, and 300. Now that I have verified my configuration, I can do one more command if I wanted to, and this command is show interface Gig Ethernet 01 switch port. And in here, you can see that the operation mode is set to trunk, and the encapsulation trunk is using .1q. The VLANs that are allowed in that trunk are 100, 200, and 300. And finally, the trunking native mode VLAN is set to 100, which is the IT department. So next, let's tackle step number 5, where we will be doing some access port configuration. So we would need to configure fast Ethernet 01 and 02 and 03. So I'll go to config terminal again, and from there I'll go to interface fast Ethernet, not Gig Ethernet, fast Ethernet 0/1. I will set the description first. That will be part of the IT department. And then I will say switch port mode access to enforce access operation mode, and then switch port, and then switch port access VLAN 100. And then I will do the same thing for fast Ethernet 02. Fast Ethernet 02 is part of the HR department. And is also going to be part of VLAN 200. And then finally, interface fast Ethernet 03. And that is going to be part of the sales department. And this interface is part of VLAN 300. So let's verify what we have just configured. I will hit the end command, and then from there I'll say show VLAN brief. And you can see, guys, that we have the VLAN ID here 100 IT department, and we have fast Ethernet 01 that is part of this department. We can see fast Ethernet 02 is part of the HR department, which it resides in VLAN 200. And then fast Ethernet 03, and that is part of the sales department, and it resides in VLAN 300. Let's do the same thing on switch 2. Let's verify this. And we have a similar outcome as well. Fast Ethernet 01 is part of VLAN 100, Fast Ethernet 02, 200, and Fast Ethernet 03, 300 VLAN. Okay, next I will go to step number 6, where we will need to push some configuration to our end devices, and these are computers or PCs. So I will log into each PC, and I will configure the IPv4 address from the IPv4 address table. And then once I have done this, I will show you the IPv4 address for each PC to save some time. Okay, guys, so I have configured all the computers accordingly, and the reason why I'm bypassing this is because I wanted to save time for you, and also I have done this in the previous videos. So if you are following along, you should know how to do this step already. So if I go to PC1 and go to the CLI, you can see that the IPv4 address has been configured accordingly. I'll do the same for PC2 and PC3 and PC4 and then PC5 and then PC6. So next, what we will do some verification and connectivity test. So from PC1, I want to ping PC4, which is part of the IT department, and they both resides in the same network. So I would say ping 192.168.101.11. And you can see that the ping is successful. I also can ping the SVI interface by saying ping 192.168.101.1. And the first echo message, it times out because of the ARP entry. We can see that there is connectivity between PC1 and PC4, even though that they resides in two different switches. Next, we will be pinging PC5 from PC2. So I would say ping 192.168.102.11. And then I will also try to ping the SVI 200, the SVI VLAN 200. You can see that the ping is successful. And then finally, I will ping from PC3 to PC6. But before I do that, I will ping the SVI first, which is 192.168.103.1. And you can see the ping is successful. We will up arrow that, and then we would set the last octet to 11. And we can have connectivity, and there is reachability between PC3 and PC6. Okay, so next let's move into step number 8, where we will be doing some inter-VLAN testing, where we are going to initiate a ping request or a ping test from PC1 to PC6. Let's see if that's going to work or not. So I would say ping 192.168.103.11. You can see the ping has failed, and this happens because layer 2 switches operate at the data link layer of the OSI model and cannot perform inter VLAN routing on their own. So even though we have configured SVI on each switch for VLAN 100 and VLAN 200 and VLAN 300, these switches cannot route traffic between these VLANs. And to enable communication between VLANs in this scenario, you would need to introduce a layer 3 device such as a router or a layer 3 switch into the network. And this would allow you to have communication between different VLANs and different departments. Okay, so that's it, folks, for this video. If you found this video helpful, please don't forget to give it a thumbs up. And if you haven't already, please hit that subscribe button and turn on notification so that you never miss our future tutorials and tech insights. If you have any questions, comments, feel free to drop a comment below. I read all your comments and I'm here to assist you. Remember, consistency and hands-on practice are key to success. So stay curious, stay inspired, and until next time, peace.